So this is start of Unit 6, inverses and logarithms. How do you find the inverse of an equation? The first big idea is that log functions undo or are inverses of exponential functions. So you might, hopefully you remember in Unit 5, it was exponential functions, and we would do like compounding interest. And I would say, well, how long will it take you to make such and such amount of money with a certain interest rate? And you basically weren't able to solve it unless you did guess and check, unless you plugged in some values for the exponent until you got close to the answer. Well, we want to be able to do that without using guess and check. We want to find it exactly. So logarithms will help us do that. Now we're not doing logs yet. We'll get to that next week, but we are finding the inverse. So let me show you two different methods. The first is a review of what you've already seen, but I want it written in your notes. So to find the inverse of f of x equals negative 3x plus 1, what we would do is we would list the steps that are happening in the original function. So what is step number 1 here? Is to, what do you do when you drop a number into this function machine? You multiply by negative 3. And then step number 2 is to
add 1.
Yep. Add 1. So for the inverse, we do the opposite order and opposite operation. So we go backwards. So step number 1 is to, instead of adding 1, we subtract 1. And instead of multiplying by negative 3, we divide by negative 3. Divide by negative 3. And just by looking at your steps, we can write the final answer. And you have to be sure to use inverse notation. So it'd be f inverse of x is how you say that. F inverse of x. And it's like a little negative 1 above the f. And that means do the opposite thing. So we're building this new function and we're following these steps. So you take your number, which is represented by x, a variable. First you subtract 1, so that's written by saying minus 1. And then you take that whole amount and you divide by negative 3. So I'm going to take that whole thing and divide by negative 3. And so that is our inverse function. And if we tried a number like, let's say 5, and you plugged it in, if you did f of 5, you'd get negative 14. And if you plug negative 14 in here, you would get negative 5 back. So you can always check. So now let me give you a different way of doing these. So instead of listing the steps, what you can do is first just write, instead of using function notation, rewrite the equation with y. Y equals negative 3x plus 1. So you do that first. And then what you do is, since you're undoing something, what you do is just swap x and y. Swap or switch the order, swap x and y. So instead of y equals negative 3x plus 1, you're going to say x equals negative 3y plus 1. So you can do some of the problems that are easier like this already. And then you solve for y. So let's do that back up here. Solve for y. So you have to undo everything around y to solve for y. So you'd subtract 1 and divide by negative 3. So you would get x minus 1 equals negative 3y. And then y equals x minus 1 over negative 3. Now, you can't leave your answer like that because they both say y equals, and now I have y equals, but if I use the inverse notation to write it, then I'm okay. So x minus 1 over negative 3. And I get the same answer as I did with method 1, but without listing the steps. So swap step number 1, swap x and y. Step number 2, solve for y. Step number 1, step number 2. And so this is all algebraically. Now I want to talk about what this looks like graphically with a different color pen. So now what do these graphs look like? You started to do this yesterday, but you might have, but you didn't have as much information then. So what do the inverses look like if you were to graph them? So I'm going to tell you, and then we'll do an example together. So one way to find this graphically is to find the inverses. You can make a table of values and swap x and y, just like we did algebraically. So you swap the domain and range. Swap the domain, which is x, and the range, which is y. So, and then what will happen if you graph the inverse on the same coordinate plane? This is a fact. I've starred them, and I'll show you how this works. A graph and its inverse reflect over the line of symmetry. And that line will always be the equation y equals x. Graph and its inverse reflect over the line of symmetry y equals x. And so to illustrate this, I'm going to do this with you. So let me go to here.